So we're going to start Chapter 7 and Section 7.1 by graphing linear systems. And the big word here is graphing. So let's just really focus on graphing. Before we deal with the linear systems part, we're going to do a quick review. So you'll need a sheet of graph paper with a coordinate plane drawn. Now, with your coordinate plane, what we're going to try to do is we're going to graph an equation. And the one we're going to graph is right here. It's y equals 2x. So we're going to really focus on y equals 2x. I want to think a little bit about, this is actually in slope-intercept form, so it's easy to graph. There's an understood plus 0 here. That's the y-intercept right there. Y-intercept is 0. The slope is going to be 2 over 1. So again, what we're graphing here is y equals 2x plus 0. So you can start by placing the y-intercept. Now the y-intercept is not 2, it's actually right here at 0. That's where y equals 0, it's right here. Okay, the next thing is the slope. It's up 2 over 1. So we're going to rise 2 and run 1. Those are both positive, so it should be right about there. And then go ahead and connect that line. And you should see something that looks like this. Now, the reason we're stopping here is we're going to examine this line. This line is actually a series of infinite solutions for this equation right here. So anything we pick, in fact, we're just going to plot some points here, some extra points. We're going to put this point right here and maybe this one right here. So I'm putting a 2, 4, and 3, 6 as points. Now we're going to put these back right up here in this equation, and we're going to ask, do these work? For example, does 3, 6 work in this equation? Well, if you put a 6 right here for the y and a 2 times 3 right there, it's going to work. So I'm just quickly showing here, this is the y value was 6 on that point, 2 times 3, the 3 was the x value, 6 equals 6 plus 0. So this one definitely works. Any point we chose along this line would be a solution of y equals 2x. Doesn't matter where you go, anything on that line is a solution, so this has multiple or actually infinite solutions. So let's go back and do the definitions here. Here's what it looks like. The definition looks something like this. The system of linear equations, here's how we can write this. Make this kind of simple. It is it's 2 or more linear equations. So those things we just did were linear equations. This is 2 or more linear equations. That's about as simple as you can get. Now those linear equations might look something like this. We might have y equals 9x plus 2, and then another one we might have is 2x plus 3y equals 1. Now those are just two separate linear equations, and our job is basically to find out where these intersect. That's what we're going to be doing in this lesson. Now the solution of a linear system, and we're really going to be focusing on using two separate equations, is going to look like this. Solution of a linear system is an ordered pair, an ordered pair, and that might look something like xy. Usually that's how we write it. So it's going to be an ordered pair that goes in this form, x comma y, that makes each equation true. So write that down, and then here's what it looks like. Over here, we have two equations, and there's tons of solutions on each one, but there's only one place that they meet, and you can see that right here. It's at 3, 4. So if we were doing this one, we're going to be looking for where these meet, and these meet at 3, 4. That's only one single point that makes both of these true. And finally, you can skip the point of intersection. We won't need that for this lesson.